I think sometimes from an anthropological perspective, maybe anthropologists have confused, because transgender populations have existed across time and culture, intersex populations across the world. I mean, one is in the Dominican Republic, a village Salinas, where 1 in every 90 boys are born female and then convert.
That's the same as the Tiwi Islands. It's very, very common.
Yes.
And we know a lot about that condition.
And
they call them make-a-man.
Well, there's a tribe in Papua New Guinea, the Sambia tribe, which is the Kowalu Atamwal. I'm sure I didn't say that properly, but it means, or changing into male thing. But in Pidgin English, and I went there, it's the turn of men. Can you talk about why that occurs?
I'm no biochemist, so I can't ever remember the name of all the enzymes in the pathway, but there is a particular enzyme that is involved in making androgens, and it doesn't work as well as its normal counterpart. So that's why these people are born looking like females, but at puberty there's a rush of androgens, and enough androgens to convert the clitoris to a penis and make a man.
The difference between gender and sex, because this is a pretty important, I mean, socially, this is an issue which has become of paramount importance. It's being discussed a lot.
Absolutely.
We've got intellectuals, I guess, talking about this to some extent. We've got people like Jordan Peterson in Canada talking about pronouns. I wonder what your thoughts about the whole social situation is.
Well, I've thought about this over many, many years, because people for a long time will ask me things about gender, and they'll really mean sex, because I work on sex. I don't work on gender. It seems to me that sex is a product of essentially your genes, and it is who you are biologically, but gender is who you think you are, who you identify with. They can be concordant, and in most people, gender and sex are concordant, but in a very significant minority of people, it's not concordant.
What I took away from your work, or your comments on some of the work that's come out of Monash University, is both the concordance and the inconcordance is biologically based.
I think there's got to be some biological basis for it, because people have done twin studies. They're not huge twin studies, but they all point to some component, genetic component. And what they do is look at identical twins who have identical genes and compare the concordance, that is both cisgender or both transgender, compare that with the general population. And they find a very significant, not huge, I think it's 30% or something like that, concordance. I'll bet you it's actually more than that, because, of course, we know that there are a lot of transgender people who don't want to come out. And so I would expect that as it becomes more acceptable to be transgender, that frequency will probably rise. We know that there's social factors as well to play, and twin studies are usually the way you measure how much is genetic and how much is social, and 30% is what they generally find, which is a considerable but not overwhelming, and I'll bet it's actually quite a bit bigger than that, but it's possible now to look at particular genes and find out if variants of those genes are more common in the transgender populations. And there have been 2 or 3 studies, quite small studies, that have said, yes, this gene, this variant of the gene is more common in transgender people. The latest one was done by my colleague Vince Harley at the Hudson Institute, and he looked at 12 genes that are all known to have something to do with hormones. And 4 of those genes had variants which were quite uncommon in the general population and much more common in the transgender population. And all of these genes would have something to do with hormone levels. So that seemed to make sense. I would bet you that if you do a full genome screen, you might well find hundreds of genes that have something to do with gender identity. Just that, if you look at 12, you're only going to find out something about 12. We've got another 20,000 or so. People are now looking at not just 12 genes, but all genes, and comparing them in the transgender and the cisgender population. And that's just mutations. So you're just looking at DNA. It's now possible to look at the expression of these genes too, and also the epigenetic modifications of all the genes in the genome. And who knows what we're going to get out of that. My guess is that it won't be just 1 or 2, 3, 4 genes. It might be hundreds of genes that add together to give people their sense of gender. As I think that's probably the case for homosexuality too. I mean, mate choice is a highly selectable thing, and we know that just in fruit flies there are lots and lots of genes that contribute to mate choice. They're genes that, if they're mutation, males will mate with males. So there'll be lots and lots of genes, and I expect there'll be lots and lots of genes that contribute to your sense of gender.
Does it then become difficult? Because I'm thinking about sexuality and at least your gender identity as being pretty complex behaviours.
The analogy I like to make is on height. I mean, height varies enormously in any population, and on average, males are 14 centimetres taller than females. But within both males and females, there's a great spread, and it's not at all unusual to have a short male or a tall female. So I would expect gender identity to be much the same. There will be, in both males and females, a spectrum, a whole distribution from very female to very male. And of
typical,
course,
you mean, in terms of
absolutely,
on average?
Typically, that's what I would expect. If there are lots of genes that contribute to gender identity, and they're not all linked, or none of them are linked to actual biological sex, you would expect to find feminine guys and masculine